All right, so here we go. We're going to do some polynomial division. So we're going to talk about three different methods. The first method we can use if my denominator, or the thing that I'm dividing by, is a monomial, which means one chunk. Or basically, if there's no plus or minus sign separating anything in the denominator or what I'm dividing by. Okay, what we can do from here is I can go ahead and just divide up these three terms on top and divide them each by that divisor. So if we think about this, first I'm going to go 4x to the 8th divided by 2x. So 4 over 2 is 2. X to the 8th over x to the 1st, because that's what it is x to the 7th. You can think about having 8 x's on top, 1 x on bottom. After we cancel that 1, I'm left with 7. Okay, next let's go ahead and move on here. And next thing I'm going to do is apply the second term and divide by that denominator. So next I have 10 over 2. Well, that's going to be just 5. All right, so we're at 5 there. And let's think about this. Now I have x squared over x. So that leaves me with just 1 x right there. Okay, finally I have 12 and no x's over 2x. So kind of my last application here is going to be this guy. So I have 12 over 2. Okay, well that's going to be 6, but then I have an x on bottom. Let's go ahead and just write this out actually before I even do that division. So let's see, we have a 12 on top and then a 2x on bottom. So can you guys see that after I do my division and simplify or reduce the 12 seconds, that x is still going to be on the denominator. So let's go ahead and say, okay, 12 over 2. Well, 12 over 2 is the same as 6 over 1. So I'm going to change this to 6 over 1, or just 6 over x. Okay? All right, and there is method 1 for polynomial division. Okay? Let's go ahead and do an example here where I need a new method. Okay, so I'm going to erase this. Okay, let's get a new problem up here. I'm going to go x squared minus 36 over x plus 6. Okay, the reason that this one is different is because the denominator or the divisor is a binomial. It's not a monomial, so I can't do that previous method. And so it has a plus or a minus, which separates it and makes it a binomial. All right, whenever I have this scenario, I know method 1 is no good. Let's go ahead and see if I can simplify or factor the numerator. So x squared, perfect square, minus, difference, 36, another perfect square. Well, that looks like a difference of squares, right? A difference minus of squares. The first and last are both squares. Okay, so then I can factor it like a perfect square. And that means I'm going to have 1 plus 1 minus. The square root of the first part, x squared, goes in the first spot. So the square root of x squared, x. The square root of the last part goes in the last spot. So the square root of 36, well, that's 6. It goes there and there. Okay, what's my denominator? That's still x plus 6. All right, looking good, looking good. Okay, maybe I'll just do some parentheses around here just to make it look nice. Now can we see, okay, well I have an x plus 6 in the numerator, x plus 6 in the denominator. So those guys are going to cancel. Okay, so what do I have left? All I have left is just an x minus 6, and that's it. So that's my answer. Okay? All right, there we go. That's method 2. Let's go ahead and do a new example where we can apply a new method. Okay. Where's my example here? How about x squared plus 8x minus 10? Okay, x squared plus 8x minus 10. And I'm going to divide this guy by x plus 2. All right, so when I take a look at this, again, I know it's a binomial, so I cannot apply method 1. And then when I look at the numerator, I might try and factor it. Let's go ahead and check it out here. So the negative 10 is going to go on top. The 8 is going to go on bottom. Okay, let's go ahead and run through some numbers here. So can I do, maybe 1 and negative 10? That wouldn't work. 2 and negative 5? No, that's not going to work. And that's about all the possibilities. I could flip my negatives. But basically, there's not going to be anything that works. It's not going to factor. Okay, so now we need a new method. What I'm going to do is basically apply long division. Okay, so if I want to, let's go ahead and just kind of like table this for a second. Let's just think about regular old long division, kind of like what we did when we were in elementary school. So if I want to do 46 divided by 3, I would set that up. I would go, okay, 46 divided by 3. Okay, well, 3 goes into 4 one time. 3 times 1 is 3. Then I subtract that out. So 4 minus 3, okay, that's 1. Bring down the 6. 3 goes into 16. Well, 3 times 5 gets me pretty close. 15. Again, I'm going to subtract it out. 16 minus 15 is 1. And 1 is my remainder. So my answer is 15 with a remainder of 1. But the other thing that I can do with that remainder is divide it by my divisor, which was 3. Okay? So 46 divided by 3 is 15 1/3. Okay, so that's a review of our long division. So something we learned a while ago, but we may not have used for a little while as well. What I'm going to do is I'm going to apply that same idea to this problem. So I'm going to say, okay, well, we want to do some division here. My other methods didn't work, so let's set up long division. All right, so what do we have going on? We've got an x squared. We've got an 8x. I've got a minus 10. All right, let's go ahead and divide by x plus 2. Okay. Now, what I'm looking for is I want to say, okay, the first term, what would I multiply by to get to the first term in here? So x times what gets me to x squared? Well, x times x gets me to x squared. So I want to go x times x to get here. What I'm going to do is I'm not going to put the x there because that would be an x to the first, which would not line up with x squared. So I want to put my x here so that I have an x to the first that lines up with an x to the first. So that's in the correct column now. So now I'm going to go x times x, well, that's x squared. X times 2, well, that's 2x. Now remember when we were doing the previous long division problem just with regular old numbers, I had to subtract, okay? But here is where it gets a little bit trickier with these polynomials, is if I just leave it like this, I'm only subtracting the x squared, but I'm not subtracting the plus 2x. So I have to subtract everything and use those parentheses, okay? Okay, so now we have x squared minus x squared. Well, that's nothing. I can put a 0 x squared. I'm just going to leave it blank. Again, this is the tricky part. 8x minus 2x. 8x minus 2x. Well, that's 6x. Here comes the part where I bring this guy down, just like we did in our regular old long division. So now I've got 6x minus 10. Here's my next thought process. X goes into 6x. How many times? Or this times what gets me to 6x? Okay, well, I need x times 6 to get me to 6x. X times 6. Is that a positive or negative? Well, it's a positive 6, so I'm going to put a plus 6. Notice how my number with no x's, my constant term, lined up with my constant term here. So now we have x times 6, which is 6x. And then 6 times positive 2 is positive 12. Don't forget, we're going to subtract. And again, don't forget that I'm subtracting everything. Okay? Subtracting everything. So 6x minus 6x, that's nothing, that's good, looking good. Now I have negative 10 minus 12. So negative 10 minus 12. I'm maybe think I owe someone $10, and then I owe someone else $12. So I owe a total of $22. And that negative 22, that's going to be my remainder. Okay? And then what did we do with our remainder last time? Okay, so I could maybe put minus 22 or plus negative 22. Either way is fine. And then I'm going to divide it by this original thing that I'm dividing the entire polynomial by, which is x plus 2. Okay? So here, if I were to take x squared plus 8x minus 10 divided by x plus 2, what do I get out? X plus 6 plus negative 22 over x plus 2. And there we go, we're done.